So when you have lots of options with regards to strategy, how do you compare them all out? And so that's what we're going to be talking about this week. And so, yeah, we have the all the introductory material. But this is called multi-attribute decision making. And the models that help you determine how to pick and choose are called multi-attribute modeling. Now, if you think about it, what is an attribute? Well, an attribute is that variable or factor that helps drive what you're thinking about. For example, the cost of how much I spend per month on gasoline. An attribute is what's the price per gallon. And there are other factors that go into my gas mileage, such as, have I been getting my oil changes and things like that. And so that's what we mean by multi-attribute. And so when you go through this module, we're going to be going through some software and some other factors, and you can see how it all plays out. And so the beginning is first identifying your problem, identifying the attributes, and then putting them into a form where you can decide based on the quantitative or qualitative. Certain things are qualitative, and you have to come up with your own scale and how you're going to weight those functions. The thing about a MAM is that when you have a really large complex system, you kind of have a feel for what's going on, but technically, do you actually know what's going on? And that's where quantification and measure is. And here's an example of a very complex system, and this is a communication system for the military, and as you can see, you have many, many different pieces. And so how we measure key performance parameters, and here's an example such as how quickly does information get out, how mobile can you be when you're moving with it, and how well does it operate with other systems. So when we look at the main parameters of measuring what we want, things like modularity, adaptability, and all, we can come up with general feelings about how we want to define our attributes based on performance. And so the first part is trying to figure out what are my options or alternatives, and then sit down and rank them between best and worst, and it's going to trade off against other things. So in terms of the model, one of the and I should probably post a link to this article, but it's called it's about problem solving, and it actually talks about how it's the most important thing that managers need to do. And so based on that, what you're trying to do is first figure out what the issue and challenge is, what's the what-if analysis, the sensitivity, how are you going to do your evaluation, and how you're going to come up with better decisions. And so these are the steps in multi-attribute modeling, and that's identifying and describing the problem, come up with the attributes, and typically trees are the easiest way to look at all your alternatives. Then develop utility functions, which means how much do I value it? If I have more of it, is it pretty linear? Is it going to be second order? Look at my alternatives and pick the best one. So here's the primary MAM structure, and that's that utility is, okay, what's my usefulness, like cost? And so based on cost, what's my utility function? Well, it's probably quantity times price per unit. And then what are the attributes that drive that? Well, what drives quantity and what drives my cost? And that's what we mean by attributes. And so what are my options for that cost? And so the example we're going to use is buying a car. And so what's acceptable for a car? Like, do we need an SUV? Can I get away with a sedan? Whatever. And so there are no... Good problem solving is about taking a large problem, breaking it into smaller problems that you're capable of digesting. And so the attributes for a car, for example, are cost, my features, and what are my options. And actually each of these I can even break down even further into more branches of the tree. So in terms of cost, it's purchase price, maintenance cost. Those are the sub challenges. My features, so it's like number of passengers, safety, comfort, is that an option? And then in terms of options, we have all of these, and these are the things like, do I want to buy or don't want to buy? But you could say this is another attribute to the whole problem. And these trees can actually start to become pretty cumbersome. And so at some point you're going to have to make a decision of what branches of the tree are you going to look at and what aren't. Otherwise you'll never get it done. However, what you can do is classify it into overall attribute toppings to make it neat. So powertrain and engine accessories, mechanical parts, electrical and electronics pretty much takes care of everything within options. And so in terms of developing the structure, do you go top down, meaning I have a problem? How do I decompose into sub-problems? Or do I start with a bunch of characteristics and keep building up until I come up with the main overall issue? And you can mix the two combinations where through iteration you can add things and subtract things and group them as you go along. So is it top down or bottoms up? An example of top down and bottoms up is marketing. Supposing I need to sell $200,000 worth of goods in order, and I'm trying to figure out how am I going to price this? Well, you can do it top down or bottoms up. Bottoms up would mean, okay, I think I'm going to sell this into a market of 1 million people, and I believe I can get 10,000 people in that market, and I need to make 200,000, so that means I got to charge at least $20 plus cost a piece in order to just break even. Now, what if $20 is way too expensive? Then you do it top down, and that's it. Okay, I need to make $200,000. What markets am I going to go into that are going to help me reach $200,000? And that's what we mean by that. In terms of your features and your attributes, some of the key concepts here are orthogonality. And orthogonality means is that they have to be independent of each other. For example, brand and price. Brand and price are not independent of each other. People are willing to pay more for brands. Therefore, there's a covariance. And when you have covariances, it starts to make the problem much, much more complex, harder to model. Your statistics go haywire. And that's because they're dependent on each other. So you want to pick attributes which are totally not related to each other, like tire life and well, actually tire life kind of goes into everything. Color. Okay, tire life and color, nothing to do with each other. What we also want to know is what are measurable, and we don't want to repeat experiments. And there are basic attributes, and they form the leaves of the tree. These is the foundation everything grows out of, and aggregate attributes. And that's where you start combining things together. And so you can look at it here, where I have a car, my utility function, which is, okay, how am I going to measure this? What do I value? And so the aggregate attributes are the things, basically we're talking about the main subheadings, is what we're really talking about. The utility functions that drive that, and the attributes or variables that drive those functions for total cost. And again, cost, the utility function is price plus maintenance cost. And so as you can see, a lot of these tend to be additive. And again, the tree can just keep going on and on and on, depending on how precise do I want to be and how accurate do I want to be. And so in the next video, we'll wrap up the rest of this discussion.